Okay, picture this. You're standing just outside a sprawling industrial complex. Thousands of gallons of volatile liquids are being pumped around you. Massive steel tanks are holding back immense pressure, and furnaces are literally burning at extreme temperatures. So what exactly keeps this massive chemical plant from descending into complete and utter chaos? Well, it all comes down to an incredibly delicate balance between raw, untamed operational power and meticulous, unyielding safety protocols.
Welcome to today's Explainer. We're going on a behind-the-scenes VIP tour to uncover the hidden mechanics of the modern industrial world. We're going to completely demystify those towering tanks, the roaring boilers, and the incredibly complex machinery that pump out the materials we rely on every single day. Let's get started.
So here is our roadmap for the tour. We're going to be hitting 5 major operational zones today: above-ground storage tanks, boiler fundamentals, centrifuge operations, industrial wastewater treatment, and finally, bulk material handling.
All right, Zone 1, above-ground storage tanks, or as I like to call them, the giants of storage. Let's get into it.
Think about something called head pressure. When you've got this colossal tank completely filled with liquid, the sheer weight of all that liquid pushes down, right? That creates a massive positive suction at the very bottom. Now, this is a vital force. It feeds the centrifugal transfer pumps so they can quickly move the liquid through the plant. But it's definitely a double-edged sword. If a valve is accidentally left open or a pipe suddenly ruptures, that exact same head pressure will aggressively force the liquid out, turning a perfectly routine operation into a catastrophic spill in mere seconds. Because the stakes are just sky high here, taking one of these tanks offline, which is called decommissioning, requires a highly rigid set of steps. A human operator has to meticulously empty the tank, physically isolate it by locking out valves and installing blinds to block any flow, and then conduct rigorous gas testing. And you absolutely cannot skip a step. If an operator makes an error with venting while pumping out a tank, they can actually pull a vacuum. The pressure difference gets so extreme that the outside atmosphere will literally crush a heavy steel tank inward like a cheap soda can. It's wild.
Moving right along to Zone 2, boiler fundamentals, the beating heart of plant power.
So engineers basically rely on 2 primary designs to transfer immense heat into water to make steam. First, you've got fire tube boilers. In these, the hot gases from the combustion fire shoot through steel tubes that are completely submerged in a shell of water. Then you have water tube boilers, which basically flip the script. The water is actually inside the tubes and the roaring hot combustion gases flow around the outside of them. Different setups, but both achieve the exact same incredible feat of converting water into high-pressure steam.
But safely generating that kind of heat, that relies on mastering the combustion triangle. We're talking a perfect, continuous mix of fuel, air, heat, and a chemical reaction. Operators have to watch this ratio like a hawk. If there's too much air, heat is just wasted right out the smokestack. Too little air, unburned fuel can build up and cause a massive explosion. And honestly, the scariest scenario is if the continuous feed of water stops. That massive boiler can quickly boil dry, and without water to absorb the intense heat, the metal tubes will warp, rapidly overheat, and violently rupture.
Okay, stop number 3, centrifuge operations, where we're essentially manipulating gravity itself to force separation.
You know how oil and water naturally separate if you just let a jar sit on the counter for a few days? Well, imagine hitting fast forward on that by applying massive centrifugal G-forces. Basket centrifuges work a lot like the spin cycle on your washing machine. A perforated spinning drum catches the bigger solids while the liquid gets pushed out. On the flip side, disc and solid bowl centrifuges handle much finer materials. They use stacked metal discs or internal spinning scrolls to force mixtures apart purely based on microscopic differences in their density.
But here's the crazy part. How do you get those separated solids out of a machine that is spinning at thousands of revolutions per minute without turning it off? Self-cleaning disc models use an absolutely ingenious maneuver called the chute. The machine triggers a lightning-fast drop in its internal hydraulic pressure. This makes the bottom half of the spinning bowl drop open for just a fraction of a second, instantly shooting the packed solids out into a discharge chamber. It happens so fast, the machine doesn't even lose speed. If it didn't do this, heavy solids would build up and violently tear the vibrating machine apart.
Let's head into Zone 4, industrial wastewater treatment, where we meticulously clean up the chaos.
After all that processing, heating, and separating, the plant has a rigorous, multi-stage defense mechanism to protect our waterways. We don't just filter the water once. Primary treatment steps in first to skim off oils and settle out the heavy debris. Next, intermediate treatment uses chemicals to literally force dissolved metals to clump together and drop out. Then, secondary treatment tackles the organic waste. Finally, tertiary treatment uses advanced filtration and activated carbon to polish that water until it's perfectly safe to discharge back into the environment. I actually want to zoom in on that secondary phase for a second, because it relies on something called activated sludge. I like to think of this step as a highly controlled biological bug buffet. Operators purposefully pump massive colonies of helpful non-disease-causing bacteria into the wastewater along with a bunch of oxygen. These little microorganisms quite literally eat the dissolved carbon-based organic pollutants right out of the water. Once they're totally stuffed, they settle to the bottom as sludge, and what's left is incredibly clean water.
All right, our final stop on today's plant tour is bulk material handling. Time to talk about moving mountains.
We talk a lot about liquids and gases, but plants also have to move literal mountains of dry solids, things like pellets, powders, and granules, using massive pneumatic pipes and mechanical conveyors. You might think dry powders are super safe, but handling them can be terrifyingly dangerous. The big four hazards are moving equipment, high pneumatic pressures, dust generation, and explosions. If a highly combustible dust cloud gets kicked up inside an enclosed silo, a single tiny spark from static electricity or a hot conveyor bearing can trigger a devastating dust explosion.
Which brings us to a vital, totally non-negotiable metric: 50%. This number represents the absolute maximum threshold for something called the lower flammable limit, or LFL. When an operator is testing the gas inside a decommissioned tank or silo before doing maintenance, if those flammable vapors test at 50% of the LFL or higher, all work stops completely. They cannot safely vent the space, and they certainly cannot enter it. Full stop. And you know, that really brings us to the core truth behind all of these massive operations. You can have the fanciest, most advanced automated controls in the world, but ultimately, the human operator is the final and absolutely most important safety protocol in the plant. It's the operator who hears an unusual vibration in a centrifuge, who sniffs the air and catches a fugitive chemical leak, who double-checks the lockout tags on a tank valve. Following the step-by-step instructions without deviation isn't just about productivity. It is quite literally a matter of life and death.
So, as we wrap up this explainer, we've gone from the crushing pressures of storage tanks to roaring steam boilers, intense centrifuge G-forces, biological bug buffets in water treatment, and the explosive risks of moving dry solids. Knowing the immense power and the rigorous safety hiding behind those industrial fences, how will you look at the everyday products they create? Hopefully, this tour leaves you with a profound new respect for the invisible industrial giants and the incredibly skilled operators that work tirelessly and safely to build our modern world. Thanks for joining me today, and stay curious.